Okay, this video is all about the solar system and telescopes. So, what is in our solar system? Well, right at the centre of our solar system, we have our sun. And orbiting our sun, we have our planets. Now, you need to know the name of all these planets and the order. And if nothing else, it's quite good pub quiz knowledge. So, here we go. Starting from closest to the sun and moving away, you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Then we have Pluto, which was originally considered a planet, but unfortunately got demoted in 2006 to a dwarf planet because it's simply too small. Sorry, Pluto. There's not just planets and sun in our solar system, there are other celestial objects too, such as moons. These are called natural satellites because they orbit around planets. And the Earth's not special to have a moon. In fact, Saturn's got 83. Other things include asteroids. These are bits of rock and metal. And you'll find loads of asteroids in the so-called asteroid belt. Also comets, which are bits of ice and dust. So that's the model of our solar system today, but it wasn't always thought to be that way. In fact, the Greeks thought that the Earth was at the centre of the solar system. That model of the solar system is called geocentric, because why wouldn't the universe revolve around us? Plus, to be fair to them, all of the stuff like the sun and the planets seem to move across the sky as if they were orbiting Earth. And that belief was held onto until roughly the 1500s when we introduced the heliocentric, or the sun at the centre of our solar system, and the model that we use today. So, how can we see all of this stuff that's in our solar system and beyond? Well, of course, we use telescopes. And the original telescopes that we're using are optical telescopes that use visible light. And you need to know a couple of things that you can do to improve the images that we can get from these telescopes. Number one, increased aperture. And I know it's a fancy word, but it just means make the size or the diameter of the objective lens bigger. Why? Because the bigger that lens is, the more light can fall onto that lens, the more we can see. And number two, get yourself a higher quality lens. Pretty self-explanatory, that one. Now we can also play around with where we put these telescopes to get the clearest image. So the first thing we can think about is light pollution. We want our telescopes to be in really dark places on Earth, away from street lamps and other sources of light that may distort the image. So we can put them in a rural place and we can put them somewhere high up, like on the top of a mountain. The other problem that we're facing is our atmosphere actually does absorb a lot of the light before it reaches Earth. So if we're really invested in getting a clear image, we should really put our telescopes into space to avoid the effects of the atmosphere. Since the earliest telescopes, there have been various developments so we can see more and more events in outer space. One of these is using telescopes that can detect different wavelengths of light outside of the range of visible light on our EM spectrum. For example, X-ray telescopes. These telescopes are super cool because they allow us to see events where X-rays are released, such as exploding stars. The other major development is using computers combined with these telescopes because they can help us to create clearer and sharper images and collect huge amounts of data. If you think about it, they can work for 24 hours a day and without the help of any humans. Hey, hope you found that helpful. Please do download the notes, give us a like and subscribe. Thanks for watching.